For this lesson, we're going to take a trip down memory lane because we're going to be focusing on finding least common multiples, which is going to be a key step for us whenever we go to add or subtract these fractions and we need to find what is referred to as a common denominator. Now, this picture that you see over here on the right-hand side, this is actually a picture of the notes that I just got done explaining to my daughter Lennon. Lennon is in 4th grade, and she's currently figuring out how to find common denominators with numerical fractions. And what I did over there is I set up a set of rules for her that would work based off just the elementary level that she's getting introduced to this at. However, unfortunately, these rules aren't going to necessarily work for us for the algebraic version. But there are still some things that we can pull from it as far as identifying factors. So let's go ahead and take a look at what our procedure is going to be. Our procedure is going to be to first factor each expression, and then identify what are the common factors and what are the remaining factors, and we'll use all that information to come up with our LCM. Now, one other thing is realize that when we're calculating a least common multiple, the least common multiple is either as large as or equal to the largest number or bigger than both numbers that you're using. We'll take a look at that here in our first example. So if we take a look, number 1 says factor the expression, but at first some of us might be confused because wait a second, 18 is a number. So when we see the word factor, we're thinking of prime factorization. So I know that 18 is 9 times 2, which then results in 2 times 3 times 3. There's our prime factorization. If we look at 72, well, we know that this is 2 times 36, or 2 times 2 times 18, which also results in 2 times 2 times 2 times 3 times 3, where we see that the 2 times 3 times 3 remains the same in both scenarios. So this is one of those scenarios that we see that actually the one number itself is going to be the least common multiple because they share a similar factorization. So in this case, we can conclude that the LCM then is equal to 72. But that's kind of a trip down memory lane with numerical fractions. Let's look at what we're going to do with algebraic fractions. So with the algebraic fraction, we're going to again start off by factoring. Well, it's nice because our first expression here is factored already. However, the second expression factors into x plus 2, x minus 2. Now, one thing we can create is something that's referred to as the box strategy, such that we can then go ahead and say, all right, what do they have in common? They both have an x minus 2. And then what's left over? Well, in the top, there's nothing left over. So if we wanted to, we could write a 1. And in the bottom, we have an x plus 2 left over. So I can write x plus 2. And then my LCM is found by listing all the factors within our box. So this is going to end up telling us that we have x minus 2 times x plus 2. Which, believe it or not, is the exact same mathematical concept as the first example, because what we'll see is that we had an expression such that the first expression actually goes into it, or we had a number such that the first number went into it. Let's look at our third example then. In our third example, we're going to again start off by doing the factorization. But again, in this case, it's kind of weird to think about this in factored form, so maybe we might just leave it as 2 times x times x. But honestly, if we wanted to, we could just leave it as 2 times x squared. And then the factored form of the denominator would be 6 times x plus 2. But I'm just going to go a step further and make the 6 2 times 3 times x plus 2. Let's go ahead and then use this box strategy. And in the box strategy, again, we're going to go ahead and look to see what do they have the same. Well, I see they both have a 2. Now, I can't say they both have an x. it looks like they both have an x, but realize this x is a factor where this x is part of a term of an expression. So just be careful with that. So that tells me I have an x times x remaining, and I have a 3 times x plus 2 remaining. So from here, I'm ready to go ahead and write my LCM. It's going to be the 2 times 3 times x squared times x plus 2, which I'm just going to go ahead and simplify a little bit further to result in 6x squared times x plus 2. So again, in summary, we're first going to start off by factoring each expression. We then identify common factors. Then we list the remaining factors. And from there, we can come up with our LCM.